Okay, this is Algebra 1, and this is Mr. Frent, and this is our first lesson, prerequisite lesson before we get to Chapter 1, Section 02 on real numbers. Before we get started, just a couple notes. I wanted to point out that you can always pause and rewind if you missed something to write down, or pause if I'm going too fast so you can write things down. That's always an option. But also I want to point out that it's important to listen to me as well as just what I write down, because there's going to be some things that I say that I don't necessarily write down, but they're still important. And it's also going to be, there may be some things that I say that end up on quizzes and tests that I don't actually write down. So it's going to be important to listen to me as well as watch and take the notes. So fill out these note sheets as we go. And then at the end, there'll be a lesson summary and a practice problem for you to work on. So let's get started here on real numbers. First, you see the box here, real numbers, and it's broken into two different sets, and we'll get to those. And there's actually a whole other set of numbers called imaginary numbers. But we're not going to focus on the imaginary numbers today, or really for a while. You'll see those later in your math careers, a whole other set of numbers called imaginary numbers. But we're just going to focus on real numbers today. So I'm actually going to kind of go out of order and go down to the bottom here and tell you what real numbers are. So real numbers are all of the above terms here that are listed: natural numbers, whole numbers, you can see them all there, integers, and so on and so forth. All of the above, and you can break them into rational and irrational numbers. So two different subsets of real numbers, rational and irrational. And so I'm going to start first with irrational numbers, and I'm actually going to put it right over here. These are your irrational numbers, everything in this box. And you notice that there's no other bubbles in that box. So there's no other subsets of irrational numbers. So that's going to lead us into what is an irrational number. Okay, so an irrational number are numbers that have decimals that never end or they don't repeat. Decimals that never end or they don't repeat. So a lot of times what you'll see there is, say, the number pi. Pi, if you calculate it out in your calculator, if you hit the pi button, I think you get, what, 3.1415976, and goes on and forever. But you notice those digits, there's no repeating digits, there's no pattern you can pick up, and it never ends. It would go on and on forever and ever. So that's the don't repeat part there. It never ends and doesn't repeat. Okay. Some square roots would actually be an irrational number too. So like the square root of 7, for example, would be an irrational number as well, because it would be 2 point something dot dot dot. And I put these dot dot dots kind of show you that it would go on and on forever. Some square roots do end and do terminate, especially perfect squares. We'll get to that, and those would not be irrational numbers. Okay, so everything on the right-hand side of the box is an irrational number, and again, those are numbers that have decimals that never end or they don't repeat. The other set of numbers here is called rational numbers. Rational numbers are numbers that have decimals that end or they repeat. So it's just the opposite of irrational numbers. Decimals that end or they repeat. So an example of that would be like 1/2. Okay, 1/2 as a fraction, we should all know that when you calculate that out, what is that as a decimal? It's 0.5. Okay, so 0.5, that decimal ends. So that would be considered a rational number. Or what's an example of one that repeats? Well, you could have a 1/3 here. A 1/3, if you calculated it out in your calculator, and it's just a simple division problem, 1 divided by 3, you'd end up getting 0.3333333 forever. And it would go on and forever. But we don't have to keep writing those 3s, so one thing we can do is just put the bar over it. I'm sure some of you guys have seen that as well. So this little bar over the 3 tells you that that number repeats over and over and over again. So that would be an example of a decimal that repeats, 0.3 bar. Or you could say 0.3 repeating. So that would be a rational number. And sometimes, just the number, like say the number 7. That'd be another example. Number 7, it ends. It would be 7.0. So it just has an ending point. And so that would be a rational number as well. Integers. Oops, excuse me. There. Let's go integers first. Integers are all positive numbers from all positive and negative whole numbers. All positive and negative whole numbers. Okay, so that would be any of those numbers that there's no decimals involved, there's no fractions, it's got to be a whole number. And then whole numbers are whole numbers that are from 0 to infinity, so you're kind of taking out all the negative numbers. So that'd be from 0 and all the positive numbers all the way up to infinity. And then your natural numbers, your counting numbers here are all whole numbers from 1 to infinity. So you're just not counting 0 because when you count, you basically start at 1. Nobody starts at 0 when you count. So again, going over these, we have natural numbers, which are your counting numbers from 1 to infinity. Your whole numbers are from 0 to infinity, all the whole numbers, no decimals, no fractions. Integers, now you're basically adding in all the negatives, all the negative whole numbers. Again, no fractions, no decimals, just positive and negative whole numbers. And then you see the rational numbers. So we go back over to this table, this graph here, and we have the irrational numbers on the right-hand side. So rational numbers would be everything on the left-hand side of the box, rational numbers. And really this whole land over here would be considered rational land. We'll put this in, say this. All this stuff here, this is rational land here. Everything out here is all those rational numbers that have decimals that end or repeat. So that's all rational numbers. And then inside there is a subset, still a rational number, but this is where integers would go. Integers would be in this bubble. So now we've left out all the numbers that have fractions, decimals. Now we're talking about all positive and negative whole numbers. And then one more bubble in then would be your whole numbers, because this would be from 0 to infinity in there. And then one more subset would be your natural numbers in here, because this excludes 0, basically 1 to infinity. So that's kind of how the rational and irrational numbers fit into our real numbers box and are split up like that. Okay, so moving on. Let's do some practice problems. So this first one, we're saying name the set or number sets to which each number belongs. So let's look at letter A. So we've got 1 6. So we can just divide this on our calculator. And if you did that, you'll end up getting 0.1666667. Okay? And the reason it goes to that 7 is because your calculator actually has a rounding function where at the last digit it has, it's going to round it up to that 7. Okay? But really what it is, it would keep going 666 forever. It's just your calculator's rounding it to that 7. Okay? So if we rounded this down, we could actually say it's 0.16 bar. So now we have a 0.16 repeating. So what number would that be? In that case, this would be a rational number that would fit along that set, because it's got a repeating decimal. It's a decimal that either ends or repeats. This one would go on 6s forever. Okay? Let's just go to letter C. We don't have to do. I'm not going to do all the problems every time. Got letter B and letter D, which you guys can do for your own practice. But I'm just going to go to letter C, and then you guys can move on from there. So we've got the number 8. So what numbers? What set number sets would this be? It has a decimal that ends, so it's definitely a rational number. So we're rational. And then is it a integer? Sure. It's a positive, negative whole number. So we just mentioned it's a whole number because it's a positive. If it was a negative, it would not be a whole number, but it's positive, so it's a whole number. And then it's a natural number because it is a counting number. So this letter C would actually be rational, integer, whole, and natural. So you guys can work on B and D on your own. Let's talk about square roots now. Square roots. What is a square root? You've heard the term before. Well, definition-wise, we would say one of 2 equal factors of a number. One of 2 equal factors of a number. So a factor is a number that you multiply by. So in this case, an example would be, say, 5 times 5 equals 25. Okay, so what that basically means is 5s are your factors, and they multiply to make 25. So since they're equal factors, 5 and 5, what that basically means is if you take the square root of 25, you would get 5. And now let's talk about perfect square. What a perfect square is. A perfect square is a number with a rational square root. Okay, so we talked about it earlier, how like square root of 7 would have a decimal that repeats or that does not repeat and goes on and on forever. It never ends. Well, that would be an irrational number. So a perfect square would be something with a rational square root. So an example of this would be, say, the number 36, because the square root of 36 would be 6. And another example would be, say, like 81. Square root of 81 is 9. It's rational. It's rational. And then let's go with a non-example. A non-example would be, say, the number 10. Because if you took the square root of 10, you would get a decimal that never ends. And so that would be not an example of a perfect square. So let's go ahead and list the next steps is list the first 12 perfect squares. So if we use this table over here and we just say that this is x and this is x squared, and then we'll just go down all the way to 12 here. And then we're just basically squaring them to get our perfect squares. Well, if x is 1, then square it. 1 squared. 1 times 1 is 1. And then in this table, we're going to go 2 times 2 is 4. And then we're going to go 3 times 3, which is 9. And 4 times 4, 4 squared is 16. So you guys can kind of fill out the rest of that table. Just square every number in the left column, multiply it by itself, 5 times 5, 6 times 6, and so on, and fill out the rest of that table. Okay, next we're going to go back to these practice problems. Again, name the number sets in which these numbers belong to. Okay, so square root of 17. If you punch this in your calculator, you're going to get 4.1, and I'm just going to go dot, dot, dot. That's going to tell me that that number, that those decimals go on and on forever, and they don't repeat. So simple enough, you should know right away that that's an irrational number just because it has a decimal that goes on and on forever and doesn't repeat. So irrational. Letter B. Some people don't know they're perfect squares, but this turns out to be a perfect square. If you punch in square root of 121 in your calculator, you get 11. And so you could kind of name what number sets that belongs to. Rational, integer, whole number, natural number, basically all of them. If we do this one, letter C here, 7 divided by 9. In this case, you're going to get a 0.7 repeating. It's going to go on and on forever and repeat. So what type of number is that? It's a repeating number. It's a repeating decimal, which makes it rational. Remember, if it repeats or it ends, it's a rational number. And finally, letter D. It's a little interesting here with this negative sign. Okay, but because the negative is outside of the square root, we can just kind of move it to our answer, negative the square root of 36. Well, what's the square root of 36? It is 6. So our answer here would be negative 6. So we know that that's rational because it definitely ends. And what else is it? Well, it's an integer because it's a positive or a negative whole number. And then that's it. It's not a whole number because it's negative, and it's not a counting number or a natural number because it's negative as well. Okay, this step here, you can kind of do these on your own. Just give a number that fits the following description: an integer that's a whole number, an integer that's not a whole number, and then a natural number. And you can give any examples of those. And now we're on finally to our lesson summary and practice problems. So in these, we do these every day. Basically, I want you to write the answer in the box. You don't have to write the question. So here's the question. You do not have to write this. Just write your answer in the box. What is the difference between a rational and an irrational number? And so check back in your notes and get the answer to that. And write it in this box right here. And then you got a practice problem. I think you got 2 practice problems here to put in this box. Number 1, give an example of an irrational number, which you should be able to do. There's plenty of examples throughout your notes. And then give an example of a whole number that is not rational. And just a hint, a little heads up, you might not be able to get an answer for one of these 2 questions. But I don't want you to leave it blank. I want you to note that and say, not possible, or no such solutions, or something like that. But just make a note that you couldn't get an answer. Don't just leave it blank. Okay, so that's it for 0-2 real numbers. And bring any questions you have with you tomorrow, and then we'll get to work on this section. Thanks a bunch. We'll see you tomorrow.